Alright guys, I'm going to go over post-test study guide pages 7 and 8 today. And then I was trying to get you some new ideas that we had to talk about so you'd be ready for the end of the study guide. We'll go back to that study guide. So we're going to start with 32 and 33. You have to remember that these are two different shapes with two different formulas, and you have to use the right formula. Remember, surface area is done by, it's like wrapping paper. So think, like I said, think wrapping paper when you're thinking surface area. It's probably the best way to look at it, I think. So remember, this is a pyramid because there is a polygon base. It goes up to 1 point. It's triangles on the side. So for number, we're going to go surface area of a pyramid. So the surface area of a pyramid. And I use S in here, but a lot of times when I'm writing, I use SA because I just like that better. So 1/2 the perimeter. That's the perimeter of the base. So that's that part. The slant length, remember, this is the slant height. This is H, okay? Plus the area, big B means area of the base. So the big B is the inside, all right, where the P is the outside. All right, so 1/2 the perimeter is 14 plus 14, which is 28, plus 14 plus another 14, which is 56. So it's 56 because it's the outside. Slant length is 25. The area of the base is 14 times 14, or 196. All right. Now, I'm just going to put that in my calculator. So I'm going to end up with surface area is equal to, so that's going to equal to 700 plus 196. So my surface area is going to be 896. Now remember, it is square inches. All right, that's surface area. Now volume, very similar. So volume, remember, it is a pyramid, so I'm going to do 1/3 the area of the base, that's why it's big B, times the height. So it's going to be to 1/3. Area of the base is 196. The height is 24. So I'm just going to put that into my calculator. So I end up getting 1,568. Now remember, it is cubic inches. So all it says cubic, it says inches cubed. It is cubic inches. All right. So that's it for 32. 33, very, very similar, except now we are using the cone formula. So we're using the cone for 33 because it's got a circular base. All right. So I'm going to start off with surface area. So surface area of a cone. The formula is right there. Pi times the radius times the slant height plus pi r squared. All right. So remember, that is our radius. That is our regular height. That is our slant length. So pi times 16 times 34 plus pi times 16 squared. All right. Now I'm okay with you putting it in your calculator all at once. I'm just showing you how you could get it. Sometimes in future math, people want it in terms of pi because pi is exact. So I just did 16 times 34 to get 544, and then 16 squared, that is 256. And then you would add 256 plus 544, and that would give you 800 pi. So you could see 800 pi as an answer, but I would probably think it's easier, and a lot of you guys are just going to do in your calculator. So you just do 800 pi, which you're going to get about, remember it's an estimation, 2,513, we'll say 0.27. And then remember, this is square meters. It's square meters because we are using it's square meters because we're using surface area, which is like the outside. It's a flat surface, really. It's like, think about it as wrapping paper. All right. So now we're going to switch over to volume. So volume, once again, we're going to use our formula. Volume is equal to 1/3 pi r squared times the height. So I have 1/3 times pi. R squared would be 16 squared times your height, which is going to be 30. So I'm going to put in my calculator. I'm going to do everything except pi. You don't have to do it this way. So I'm going to do 1/3 times 256 times 30. So I know 1/3 times 30 is 10. So I'm going to do 10 times 256, so it's going to be my volume. If you were giving me in terms of pi, it could be 2,560 pi. So I'm just going to do 2560 times pi. I end up with, your volume is 8,042. We'll say 0.48. And this time it's meters cubed. All right. So that's it for 32 and 33. All right, so 34. Which three-dimensional figure results from rotating the triangle 360 degrees about AC? So the first thing you have to do is you have to be able to understand what AC is. If you don't know what AC is, you're probably going to struggle there. So that's the first thing you got to do. So the first thing I'm going to do is to figure out AC. So when I do this, I'm going to, this is AC. All right. So you're going to rotate it. That means it's going to spin. So imagine that spinning all the way around, which means that's going to kind of spin, right? It's going to keep on spinning. So to me, that circular base, it's going to end up looking like this. So the bottom's going to make a circle, right? And that triangle, it's going to kind of go all the way around. I'm trying to think of the best way to draw it. Right? And that middle line is actually not going to be part of the figure. Right? So it's going to kind of go all the way around. And to me, that looks like a cone, right? So it's going to be a cone. All right, 35. Remember, we have some properties with parallel lines. See how this is parallel? So this line right here is parallel to that line right there. Now, there's a bunch of things we could do here. One of them that you could do is, there's so many different ways to do this, to be honest, now that I'm looking at it. I would find x first. So first I'm going to find x, because triangle have 180 degrees, right? So I know this is 90, so I have 90 plus 40 plus x has to be 180. So 90 and 40 is 130. Then I subtract the 130 over, so x is going to be equal to 50 degrees. So I know that's 50. All right. So I know x is equal to 50 degrees. There's a bunch of different ways that I could do this again. I know that this is 90 degrees based on corresponding angles theorem. I know that this together makes a line. So another thing I could do to find y, I could say 180 equals, and based on corresponding angles, I know that is 50, is that 50 degrees plus y minus 10 equals 180. So 50 and 10 minus 10 is 40, so I get 180 equals 40 plus y. So y is going to be equal to 140 degrees, which makes that angle 130. All right. So y is 140, x is 50. That's it. There's a bunch of different ways to do that one. Using either triangle properties, quadrilateral properties, corresponding angles theorem based on parallel lines. So a bunch of stuff. All right, 36. Triangle XYZ is shown. Which triangle must be similar? A triangle that measures 40 degrees. Triangles can't measure 40 degrees, so that's not possible. All right. A triangle with angles that measure 40 degrees and 60 degrees. Well, if I know, if this triangle right here, let's say I had a triangle that had 40 and 60. All right. So if I was for B, if angle 1 is 40 and angle 2 is 60, that means angle 3 has to equal 80 degrees, right? And what we have to know, guys, is the rule about similar. Similar means all three angles are congruent. Not the sides, but it has three congruent angles. Imagine I did something like this, right? And then what I did here is I made it bigger, all right? These are similar triangles because this triangle right here has the same three angles, but now the sides are different. They're different lengths, right? It's like, or I can even make it smaller, right? This triangle, these are both similar to each other, right? So that's how that works. So there's no way B is going to work. All right, so we can cross off B. A scaling triangle with only one angle that measures 100 degrees. So this is important. This is interesting. All right, so scaling. All right, so scaling, if you recall, three different sides, which we found out about triangle properties. That means it's going to have three different angles. All right. Now this is assuming that one of these angles could be that one of these choices could work. All right. So if it's scaling, it has to have three different angles. I know this is 40 degrees. Right? So the only way you could have a scaling triangle with 100 degrees is these two cannot be the same, because this would have to be, they cannot be the same. Right? So there's no way it's C. So right away I already think it's going to be D. Well, let's think. A isosceles triangle with only angle that measures 40 degrees. Well, that's isosceles, right? That's isosceles. They have measured 40 degrees, which means that last one's 100 degrees, so it's going to be D. Now, the way that's worded, that could be changed. I could probably word that a little bit better, so it's not a big deal if you don't understand that one. The wording's kind of messed up. 37. A figure is fully contained in the quadrant. It is transformed as shown. All right, so I'm going to get a quadrant up here. All right, so we have a figure. It doesn't matter. We'll call it. We'll make a triangle right here. So here's my triangle. Oh, sorry, I messed up. Is a quadrant is fully contained in a figure is fully contained in quadrant 2. Remember, this is quadrant 1. This is quadrant 2. This is quadrant 3, and this is quadrant 4. All right. A figure is in 2, so that means it's right here. I'm just going to make up a figure. We'll make a square. Actually, it'll probably be a little bit easier. Now, it begins with a reflection over the x-axis. So the first thing to do is a reflection over the x-axis. That's this line right here. This is the x-axis. Imagine that was like a fold line of a paper. If I folded that, and like this, imagine this was like wet paint. Imagine this was wet paint. If I folded that, and it was wet paint, the reflection would go right here. So that's after that. All right. The next thing is a reflection over this line right here. All right. So, like I said, I always imagine like it's wet paint. So y equals x is that line. If I folded that, right, I think the figure is going to be right here if I folded that. All right, still in quadrant 2. Now a rotation about the origin, so 90 degrees clockwise, counterclockwise. So that means basically I take these points and I rotate them 90 degrees. So I'm going to basically rotate it 90 degrees. So if I rotate that, I'm just going to slide it 90 degrees. It's going to go on this basically circle. And I think the easiest way to do that is instead of rotating, yeah, there we go, it's working now. So see how that's a rotation. I'm not meaning to make it bigger and smaller, but this is a rotation if I make it, this is clockwise, right? That's 90 degrees clockwise. So here, it's not perfect because I'm freehanding it. There's 90 degrees clockwise, but I'm going to there's 90 degrees counterclockwise. Alright, so that is about where our new figure is going to be. So, looks to me like it's going to be in quadrant 4. That's it. Alright, 38, find the slope. This one's pretty easy. Remember, slope is equal to y2 minus y1 all over x2 minus x1. Here is going to be x1, y1, x2, y2. You can change it. You can make either one x. You can make the first. You can make t x2 y2. You can make v x1 y1 as long as the 1s and the 2s are together with the same point. So I'm going to plug it in. I'm going to put 8 minus negative 5 all over. So I did 8 minus negative 5 all over 6 minus 2. So 8 minus negative 5 is going to be a positive 13 because it's subtracting negatives like adding. 6 minus 2 is 4. So my slope is going to be 13 over 4, which is A. That's it. We can actually go further and find the equation in line if we wanted to. And we did some fire starters like that. 39. So we did this before. We found out some information. We found out that if you have a quadrilateral inscribed by a circle, we found out that those two angles together equal 180. So I know that 83 plus y equals 180. Remember we googled that. Now I'm going to subtract, so y is going to be equal to 97 degrees, which is B. And that's it.